Swayam Prabha. Digital India. Educated India.
Let us start this lecture about the material technology, and we will be discussing basically about metals and metallurgy in ancient India. If you recall that in the last 31 lectures we have basically discussed about glimpses of ancient Indian science and technology. Later on we moved to the agriculture, and then subsequently to the housing and textile, and of course towards end we are discussing about water management system in ancient India. And today we will be discussing about metal and materials, and let us look at basically wonderful world of materials. And when you talk about materials, that plays a very important role in not only in ancient India and also in the present time, because we are now having the materialism which is very predominant in our life. But if you look at the Indian philosophy, they are always for the material, but not that blatant materialism that is going on. So I will be trying to draw your attention to the philosophy of Sankhya, which was very much talking about what we call Prakriti and Purusha. When you talk about Prakriti, is basically material. And if you look at like our way of life, what is being talked about in the Indian philosophy is basically the dharma, artha, kama, moksha. If you want to realize the artha and kama, then you need to play with the materials, and material plays an important role. When you talk about materials, basically we need to understand what is the basic science in it, and also how to utilize the understanding for developing certain technology which will be achieving the desire and also the artha, the material kind of things, such that or the needs, so that you can achieve the ultimate goal, that is the moksha. So when you talk about this Prakriti, we are a part of the nature, Mother Nature, and keep in mind that Mother Nature is a great designer of all the materials what we see, and also their various products. And modern science and technology try to what you call mimic them, not in a very nice way, but at least attempted to copy it, and also spoiling certain process. And when you talk about this, also we need medicine, and materials are important so for preparation of medicine which is required for a health of not only the human beings, also the other living and non-living beings around the world. So therefore we need to take care of the Mother Nature as a whole, as we are a part of it. So we need to look at the metal and metallurgy in that part. Let us look at the world of materials. And in ancient times, the materials being used can be classified into 4 categories. One is metal, and other is ceramic, polymer, and composite. If you look at metal, the various kinds of metal are were being used in ancient India. Of course, we are always being fond of gold and silver, apart from copper and also the iron, and beside this there are alloys, various kinds of alloys kind of thing, like your bronze and then brass and several other things. Ceramic of course was being used earlier days in various forms, like if you look at, we talk about the potteries and then glass and several other things we use. So ceramic comes into. Polymer were being used earlier, but most of them are derived from the what you call biology, or the polymers were basically from the natural polymers, or polymer was a natural nature, unlike in modern time where we use unnatural polymers. Nowadays people are talking about biodegradable polymer, that is why. But when you combine all these kind of things together, you may get another material which is basically composite. That means will be various combination one can think of, like metal and ceramic, you can think of composites, also metallic, ceramic and polymer, various permutation combination you can. In ancient India you may get some of the examples of composite material, for example like brick making. In the brick itself we use the ceramic like clay, and beside this we will be using some kind of a sawdust and other things. Even I was told that people were having the bow made of composite materials earlier times, which was a very light in weight and also the accurate in the flexibilities for this thing. And beside this, for the wall and even for motors and other kind of ingredients, composites are being used. So if you look at although the today materials have improved a lot, and then varieties are there, but earlier time most of the things were natural in nature, not they were making themselves, or although they are processing, but they were not designing them what you call the way it is being done in modern time. So now a question might be coming to your mind, that does India have a strong metallurgical background in ancient time? Certainly yes. We look at the background of it and look at historic chronological order how it was developed. If you look at 100 million to 4000 BC, there is a basically pre-Harappan period where people were using the gold, copper, possibly maybe meteoric iron kind of things. And of course the 3500 BC onwards, like Indus Valley civilization, where people were using silver, lead, arsenic, copper, and also of course other maybe, but also their alloys being used for their day to day affairs. Of course Indus Valley civilization was agricultural really mostly, but apart from that they have also used some these metals. And it was also being talked about, they were knowing the foundry technology, because of, if you recall that I had shown you earlier a dancing girl statue which was basically cast in. And more research has been going on today also to find out how they were doing. Even I was told that the last works cast method, which is also known as investment casting, was also there in the during the Indus Valley civilization. And if you come to the Vedic period, which is around 1500 to 2000 BC, apart from the silver, gold and other coppers and other alloys, they were started using iron profusely, and also the steel and metal works were developed, and besides this they were also using the distillation process. And of course later on the 600 BC onwards, that is there is a rise of Magadha, there is a various amalgamation of the metals were being done, and they also had developed some soldering technique and brass gildings, because they have started using also brass in a number of ways. So if you go to the Buddhist period, something around 500 BC onwards, and it was being mentioned that wood steel was developed at that time. Matter and atomic theory was also developed during that time. If you go to the Mauryan dynasty, particularly from Chandragupta and Asoka and other things, the 321 to 180 or BC, there is a method of cupellation they had found out, and beside this they had other refining technology. Cupellation is a basically refinery process of separating the precious metal like gold, silver from the base metal, in which like ores or alloyed metal are oxidized to high temperature, and the base metals are separated by absorption into the walls of cupel. We will be discussing little bit more about cupellation later on. And 600 to 700 CE, you will find the, of course, the northern portion was invaded by Huns, and then of course in southern portion Chalukyas and Chola empire were existing. There was extensive use of iron, steel, even mercury, zinc, apart from your copper, gold, silvers and other things. Of course, 1000 CE, the northern was subjected to Afghans raid, and a lot of things lost in the process. Of course, the southern side was not affected, and lot of metal works were going on in the southern side of the country. And 1100 CE, Hoysala is a very big empire, and then like brass and bronze casting was profusely used in the southern part of the India, apart from the other usual metal work. And of course, during 1300 to 1572, Mughal Sultanate was there in the northern India, and while the Vijayanagar empire was in the southern part, and both were using the metals and metal crafts for preparing for the war, making guns, and apart from your jewelry and other day to day materials. So, of course, later on 1498 to 1707, like there was a industrialization of iron, steel, brass and bronze, and I think the British also enter into these pictures along with the French people, and there is of course a war in between the British and also the Tipu Sultan during 1605 to 1761, and this is of course the British Empire time, and where modern metal technology were used for making the rockets, and also the iron guns were being developed. So, if you look at the metal and metallurgy, basically was a part and parcel of Indian life in ancient time. So, if you look at archaeometallurgical evaluation method at this moment, if you want to do, then we will have to follow certain principle, that is occurrence of mineral and their processing technology one has to identify. Not only that, also details regarding excavation sites, settlement and industries one has to also look at. One should have some experience in the related field so that you can identify what are the things going on, and evaluation of socio-economic networks, what was prevailing at that time, and also we need to look at what was the environment at that time which was instrumental for the growth of the technology, what it was prevailing in ancient time. So, when you look at the study, you will have to look at in a totality, not in isolated manner. So, that is the important message we need to learn, and it is not only for the metallurgy, but for other things, other technologies as well. If you look at the life cycle of archaeological metallic artifacts, what we can get and identify, and then try to find out that when it was, how it was being fabricated and how it is evolved, then of course the natural world that provides the basically ore, and once we get the ore, we will have to smelt it, and when you smelt, there will be also the slag which will be produced, right. And out of this smelting we can get the bloom, and then when we smith also we get the slag. See, if you look at the slag, again will be coming out of the smithing, and we can produce some artifacts, and artifacts when you use like you can use and then you can discard also, but you can also preserve it, right, and you may lose it. And when you do that, like it can be, all these three things can be again coming to the potential artifacts. And when you talk about this potential artifacts, it may corrode, or there might be some corrosion. If there is a corrosion, it may go back to the natural world, right, it may go back to the natural world due to corrosion, right. And of course, these potential artifacts you can recover, you can analyze it, right, you can display it. After recovering this potential artifacts, you can display it, you can analyze it to find out what are the components. I have put that thing in a little cycle manner, that not that the way it is linearly it is being shown in this. So, if you look at when you talk about these artifacts, basically it will be used, and it can be also what you call, when you use, you can discard also, right, you can discard it. And when you discard, you may also lose it. And when you there might be some loss, and then we will go to the potential artifacts, and then we can reuse it also, that is another way. And once you do it reuse, because the discard it will be reused, then you can get to the smithing, and smithing, when you talk about, there might be a slag, right, a whole cycle it goes on. So by that way one can look at this, archaeological metallic artifacts to find out how good or how bad, and then for your analysis. Now let us look at a brief history of the Indian metallurgy. And of course there was a metallurgy in the Indus Valley civilizations, what we are calling now Indus Saraswati civilization, or Hindi mein kehte hain Sindhu Ghati Sabhyata, right. And as per the R.S. Sharma in 1988 has written an article on historical archaeology of India. Of course, I have taken that from the History of Technology India volume 1, edited by A.K. Bagh, INSA, New Delhi. According to R.S. Sharma, several metals were being used for making various tools for agriculture, defense and transport by land and sea. And he has given lot of examples, Rig Vedas, Shrutis and Yadur Vedas. There is another author also, Prakash, mentioned the importance of fire discovery for processing of metals, and the Rishi Angirasa is considered to be the discoverer of fire, because fire is the prime mover of all the civilization what we can think of. So therefore also he has mentioned that the Yajna Kundas, the fire places, like was a open laboratory where lot of experimentation might have been done, and they might have learnt a lot about the metal and metal processings, but unfortunately they didn't write down in a very systematic manner, except in a very cryptic way they are mentioned in the Vedas. There might be the reason is that, like people were transferring the knowledge from one generation to another, but in their own clan or in their own family, but they were not giving to others. That might be one of the reason why they didn't write it down very elaborate way. And even that kind of mindset is prevailing today, because why I am saying with confidence, one of my student who is from Trivandrum, like his family was having a what you call technology of making the idols using the lost works method, and I asked them to make a video for this course, and then so that we can show, but he told it cannot be done because it is secret. So therefore even today it is happening. So it might be the one reason what Prakash has mentioned. And beside this, if you look at native metals like gold, silver, copper, iron have been the first to be discussed as early as 6000 to 1 million year BC in India, that he has claimed. And of course you will get a lot of information about the metal and metallurgy in the Arthashastra. Although if you look at earlier days, people are using arrow kind of things here, right, and arrow and the bow, and some people say that the bow will be little flexible in nature, but arrow will have this is the metal. So which were being very much being used in ancient India. If you go to our mythological stories and other things, you will find that our warriors were carrying the bow and arrows. If you look at the Arthashastra, which is the one of the earliest Indian text, has mentioned about mineralogical characteristics of metallic ores, other mineral aggregate rocks, and I will be discussing some of them. And of course they have not described the way modern people are familiar with, but however from their description one can find out that those are these materials. It recognizes also the ores in the earth, in the rocks or in the liquid form with excessive color, heaviness and often strong smell and taste. These are the things they were using for characterizing the ores and materials, like a color, heaviness or a smell, taste. So, and he has mentioned a gold bearing ore in that text. In the similar manner, silver ore was described in Arthashastra, which seems to be a complex sulphide ore containing silver, and they mention that this ore will be having color of a conch shell, and they have also talked about the camphor and bimalaka or pyrites. The Arthashastra describes the sources and qualities of good grade gold and silver ores. Gold smelting was known as Suvarna Paka. Like Paka means basically cooking, and they are talking about cooking of the gold, that is the Swarna Paka. As I told that this is the gold ore which looks like the whatever the description they have given in the text of the Arthashastra. So, this is about copper ore, and the color wise you can see, and from this one can identify. According to the Arthashastra by Kautilya, the copper ores were stated to be heavy and greasy and tunny, and this, if it is of course kind of these things, then it is one can identify that color as to be chalcopyrite left exposed to air and then gets tarnished. And there might be some other varieties of copper ore, that is a green color of malachites, and there is a dark blue with yellowish tint azurites and pale red native coppers. There are various kinds of copper ores are being mentioned in the Arthashastra text. Lead ores were stated to be a greyish black like kaka meka, means color of galena. If you look at the galena, looks like that, is the lead ore, and this kaka meka, the color of galena is a black, greyish black, looks to be the similar one that of the galena, right. And there are some other things like yellow like Piesian bile marked with white lines, quartz or calcite gangue minerals, and smelling like a raw flesh, odor of sulfur. They are having these characteristics to identify the ore which happens to be the lead. So, iron ore was known to the greasy stone of pale red color or the color of a Sindhuvara flower or hematites. Of course, there are various kinds of iron ores are mentioned in some other text, which I will be discussing little later on when we will be talking about iron and its uses. So, Arthashastra also describes system of coinage based on silver, copper. They are having a very standard units of measuring the weight of these materials in a silver and copper coin. They use masaka, half masaka, quarter masaka, known as kakni, and half kakni also. Like if you look at they were having using for gold a different kind of masakas, and then for silver different kind, both are not same weight kind of things. And copper coins progressively lower weights as compared to the silver at same composition, like 1/4 of hardening alloys and rest copper. So, copper they might have use a alloy as a coin. And let me show you a coins for Asoka. This is a basically a silver coins which were made during the time of Asoka. And when you talk about this metallurgy of pure metals in India, then we will talk about various processes. For gold, there is a gravity separation which we will be discussing, and silver and lead roasting and reduction of smeltings, copper carbothermic reduction of cuprites, and iron and steel smelting of iron ore. So, we will be discussing all these processes how Indians were making in ancient time. So, if you look at gold, gold is a very ductile metal, and it has a higher corrosion and oxidation resistance. 1 gram of gold can be drawn into more than 1.24 kilometer long wire without any intermediate annealing. So, that is why it is being used very easily for jewelries. Very nice jewelry you can find even today. although it was being made earlier days by hand, nowadays machine is making. And I always emphasize that a hand is should be kept, or the what you call this art of making the jewelry by hand must be kept, so that mind will be developed. But as gold is a soft material, then it cannot be really used for any war weapons or any other places where the hardness is called for. If you look at, according to researcher, Neolithic man around maybe 4500 2000 BC would have the first become acquainted with native gold in India. In India, not many gold artifacts dating to the pre-Harappan period have been reported. That is a very contradictory statement, but however we couldn't get much. But in Vedic literature, gold has been mentioned several times as Hiranya. So therefore, it might be Vedic period gold having a prominence, and recurrence of this metal in Copper Age, particularly 5th millennium, is more common, and many artifacts have been reported from South India. And even today also, in South India, the gold is considered to be the very important, and they are having lot of gold ornaments, and also they hoard a lot of golds. So India has the distinction that the deepest ancient mines in the world for the gold come from the Musky region of Karnataka, with carbon dates from the first millennium BC. So this is one of the oldest gold mine in the entire world India is having, and that I have shown here. This is still it's people are using it, and they have done the open cast kind of things. They were using very road in different ways. Kolar and Hathi gold mines were being worked even in prehistoric time, and it has been proved beyond doubt that South Indians had learned the technology of mining gold, established the smelting technology on a commercial scale, and metal was being traded through the Lothal by sea route to the Harappa, Mohenjo-daro, even Egypt, Greece, Rome, and Africa and other countries. With this, we will stop over here.